Our next topic is graphing the sine and cosine graphs, but now we're going to be considering vertical shifts. Now, as I'm hoping you recall from your great days in basic algebra class somewhere, you talked about the basic shape parabola. This is f of x is equal to x squared. But you knew that if you say g of x is equal to x squared plus 3, you know that if you add or subtract outside the primary function, let me emphasize what I mean by that. This is adding outside the primary function. This is adding inside the primary function. The primary function here is the square function. This is adding outside the primary function. This is adding inside the primary function. Outside the primary function, inside the primary function. We will consider this later. So we're going to kick this can down the road. But this is the topic for now. This is adding or subtracting outside the primary function. And what that corresponds to, remember, is a vertical shift. If it's plus, you shift up. If it's minus, you shift down. All right? If it's plus 3, shift up. If this had been minus 3, we shift down. So in this case, it is this picture. Think of taking this parabola, pick it up, lift it out of the picture, move it up 3 units, put it back in the picture. 1, 2, 3. And you could plot points if you wish, but that's the basic occurrence here, is we're shifting this up 3 units. If we had h of x is equal to x squared minus 2, that would correspond to shift down 2 units of the basic square function. And within the limits of my badly drawn picture, there's my picture. Well, there's nothing magic about the square function. This works on all the other functions. If you have f of x is equal to absolute value of x plus 4, that's the basic absolute value function. 1, 2, 3, 4. Shift up 4 units, and you're good to go. So adding or subtracting outside the primary function corresponds to a vertical shift. Well, that's true not just of the algebraic functions. That's also true of the trigonometric functions. And so in an exactly similar fashion, we now consider suppose we have sine of x plus 4. Now, I should caution you. Sometimes you'll see it written this way. Sometimes you'll see this 4 written in front. In fact, very often, with trigonometric functions, very often this plus 4 is left to put it here in the front. And so we write f of x is equal to 4 plus sine of x. These are the same effect. In any case, you're adding, this is a positive 4. You're adding positive 4 outside the primary function. Now, you do need to be a little bit cautious. Be very cautious here. If g of x is sine of x minus 3, then if this is put in the front in this fashion, very often what you will see is this. The sign goes with the value behind it. So you'll see negative 3 plus sine of x. This is good for us because it tells us we're shifting down, but this tells us our basic shape is still the positive sine curve. So it's very important that you keep this negative. The sign goes, the signum, the negative sign goes with the number behind it. The negative goes with the number behind it. So it would not be correct. It would not be correct to rewrite this as 3 minus sine of x. That is something different entirely. So if this is written as sine of x minus 3, sometimes, very often, textbooks write it this way. So you should get used to seeing this both ways because you don't know going forward which method you're going to be seeing when you encounter this in practice. So I will freely in my examples go back and forth between these two formats specifically to make sure you're getting used to seeing it in both ways and you know how to handle it in both ways. So first things first. All right, start the same way as before, basic shape. The basic shape is positive sign because this is positive. Let me get rid of my little arrow here. So the basic shape is a positive sign. Amplitude. The amplitude is absolute value of 1. It's not just 1, it's the absolute value of 1. You might think there is no coefficient. Yes, if there is no coefficient, we assume it to be 1, and so we take the absolute value, and if you wish, you may write that as 1. That is not required. But now we also have this value to take into effect. And so remember before I said we will consider more detail later on. Well, here it is later on. I like that you can see my Kansas City Chiefs here. Anyway, so every time you graph one of these, basic shape, every time you graph one of these, amplitude, and then every time you graph one of these, from here on out, whether there's a plus 4 here, doesn't matter what else. Every time you graph a sine or a cosine graph, every time you graph sine or cosine, you need basic shape, sketch in, amplitude, write that out. And the next thing is shift. If there is no vertical shift, the ones we were doing before, there was no vertical shift. In this case, there is a vertical shift. And so you would say up 4. That way I know that you know. And if you write this down, I will be very forgiving of the quality of your picture. If you don't write this down, I don't care how good your picture quality is, you're not getting full credit out of me. All right? You write up 4. If this were negative, you'd say down 4. If this were not present, you still need to write this. If there is no vertical shift, I want you to write shift and then the word none. If there is no vertical shift, then you write the word none. That way I know that you know you're supposed to check it. If you don't put it, then for all I know, you forgot about it. So every time shift, you either put what the shift is. In this case, you'd say up 4. If there is no shift, you say none. And so we'll say up 4. There actually will be one more line here as we consider one more level of complexity. For now, that's all we're working. There is going to be one more level of complexity here. And we'll get to that in just a bit. All right. So now we go to our graph. The thing is this. Think about the axis. The axis is no longer at the x-axis. The axis gets shifted up 4 units. So the axis, the line that contains the nodes, is no longer the x-axis. It is at, and I got to be careful of my scale, 1, 2, 3, 4. Oh, it's not quite that bad. 1, 2, 3, 4. This is now the axis. This is the axis. The x-axis value I'm taking this picture, picking up, moving it up, put it back in the picture, right? So it's the axis here. And then you add 1 because of the amplitude. The peak line is now at 5. And the trough line is now at 3. Because the axis got moved up 4 units, the peak line got moved up 4 units, and the trough line got moved up 4 units. Everything gets shifted up 4 units. So there's the axis, there's the peak line, there's the trough line. Let me go ahead and put my horizontal scale in. There's 3, so there's 3, so there's pi. Double that is about here, that's 2 pi. Half of that is pi over 2. Half of that is 3 pi over 2. And then there's one side, there's one side. So there's my rectangle. That curve needs to go in that rectangle. Put in the 5 basic points. Node, peak, at pi over 2 there's a peak. If you want to, go ahead and that's fine. If you need to make your little lines to make sure you're square up, that's fine. So node, peak, node. If you need to, you don't need these vertical lines. That's just to line things up a little bit. Trough, at 3 pi over 2, there's the trough. And at 2 pi, there's the node again, and then play connect the dots and make the dots big. And that's fine. So this is the basic shape. Amplitude is still 1, it's shifted up 4 units, and there's the graph. This doesn't take quite so long if you don't explain it as you go. And so what we'll do now is go through several little examples of this, and I hope that will get you the feel for how these work out. So the next video we'll run through 4 or 5 examples of this with the various shifting and with the various positive and negative amplitudes.